Recognize Ranking Member Marshall for 5 minutes.
Thank you, Chairwoman, again. Dr. Jacobs, we have a saying back home in Kansas that if you don't like the weather, just wait an hour. And my question is, how does your new innovation, the Earth Prediction Innovation Center, going to help my constituents, my farmers more particularly? And just to give you one example, people think of agriculture and weather as all it matters if it's rain or not, but take something as simple as alfalfa. You cut the alfalfa, there's probably about an hour or two each day that the humidity is maximum for locking in all the protein in those leaves. If you wait too long, it dries out. If you wait too long beyond that, that afternoon thunderstorm is going to pop up. And if you do it too soon, there's too much moisture in it. So how's this EPIC going to impact my farmers?
There's a couple different ways. So starting from the longer range and coming back into the shorter range, we're actually looking at seasonal to subseasonal forecasting with the dynamic climate models, as well as some statistical models. I think for long-range decisions in agriculture, that's going to be very helpful. On the shorter range, with the convective allowing models, we're going to be looking at doing probabilistic forecasting. Right now, the capability to predict a tornado is not within the science, but we can predict the probability of a tornado. And so we have a couple of things we're working on here. One of them is what we call warn-on forecast, where instead of actually waiting to see when the tornado appears on radar, we actually have the capability in the forecasting to simulate rotation in the thunderstorms and issue warnings before the tornadoes appear on the radar. That can extend the lead time slightly. The other thing is social sciences. So one of the things that we learned in some of the social science research was that humans aren't necessarily rational, and we have to think really smart about how we message the warning. If we give someone enough lead time to make a decision, but on the other hand, if we give them a lot of lead time, they might not make the same decision. So the last step of this is actually interfacing with the emergency management community and also looking at the social science aspect of it. Your statement about the moisture in the crops is interesting and also actually ties into the land surface modeling. So one of the things we've noticed with the land surface modeling is that the transpiration in plants over fields versus plowed fields can actually induce convective activity. So this is something that we're looking at, but it's at a very high resolution, and some of the satellite data we collect is critical to this.
Okay, maybe we'll move on here. I'm sure we could continue to have that discussion. There's more to talk about. But next is, I understand NOAA is fast approaching the end of its current contract for its weather and climate operational supercomputing system, WCOSS. I'm sure you've got a pronunciation for that. A priority of this administration, and we'll need to enter a new contract. Can you explain the importance of this system for NOAA's mission? And are there any limitations in how NOAA must enter new contracts, such as the ability to enter multi-year contracts to reduce costs?
So WCOS is critical to our mission. This is our high-performance computing where we run all of our operational models. The procurement process is a little bit tricky. Typically, we will go through a third-party vendor to do the procurement, but when they do the procurement, they actually acquire the hardware from the actual vendors. And so what happens is when this procurement agent goes to acquire the hardware from the vendors, they don't want to get stuck holding the bills. So they will actually ask us to put what's called a cancellation liability fee, essentially money in escrow to protect them in the very rare chance we might back out of the contract. What happens is we have to essentially park $50 million in escrow to protect them from us backing out. That $50 million is $50 million less of HPC that we actually can use for computing resources. And if we're on a 3-year rolling renewal of the lease cycle, we'll almost have to have this money parked indefinitely to protect us from that.
Okay. Thank you so much. I'll yield back the remainder of my time.
Thank you very much.